Okay, in this video set we're going to look at page 64 of your workbook, Applications with Systems of Equations. It's section 5.4. And you should be familiar with these types of problems. We're just going to set them up as a system. This allows us to have two equations that work simultaneously together, and we could use different methods, not just the substitution method. We can use graphing, we could use substitution, which I'll do in this first couple, but we also could use the process of elimination as well, which really works well for some of them. That's the best method. So the kind of concept and skill work is similar. There is one little twist though, so we'll look at that. So if we have 105 people attended a concert and tickets for adults cost $250 while tickets for children cost $175 and total receipts were $228, how many children and how many adults went to the concert? So this should look like a familiar word problem to you, and you've usually just figured it out in X in terms of Y or in terms of all the other stuff. Now we're going to put it in Y form. So we're going to say, if we have two unknowns here, we're going to say let X equal the first one, so we'll call that the number of adults. And then instead of saying let 105 minus X equal the number of children, we're going to say let Y equal the number of children. So whatever the other thing is, we're just going to call that our other variable. So then we end up with two unknowns and then two equations, so therefore we can solve. So this is a quantity and value type problem. So we're going to set it up along the lines of the same way we've done before. So we'll have quantity is represented by X plus Y equals 105. So that's my totals. And my value, my money part, is set up as $2.50 or 2.5. You can just write 250 X plus the $1.75 for the children's tickets times the number of children tickets, right, equals $228. And you guys have done similar problems to that, but you've done it this way where we've done by substitution, really. Y equals the total 105 minus X, and that's represented or representing the number of children. So you've done pieces that look like this before, right? You've done let X equal number of adults and let number of children equal the total minus, the part that was the adult ticket. So same idea here. Now we're going to substitute this expression in for Y into our other equation. So we're using our methods of solving by substitution. You could also graph these, and where they intersect would be your answer. You'd probably want to use technology because there's some decimals and things, but it's an option. And you also could just multiply one of these through by like the opposite thing here, the negative 250, every term to solve by elimination if you wanted to. We'll do some like that later. But for now, we're going to do solving by substitution, and you can pause the video at any time, but this is a really good review. But you can pause and just work it out, and you may be able to do a lot of these on your own, but try to set it up as a system instead of how we did it before in chapter 4. This is a new tool that we have, is creating systems. So that's what we're focusing on here. That's the objective, not to just do the default, because as things get more complicated and you need to set up multiple equations in higher math, you might have 3 unknowns, 3 equations, 4 unknowns, 4 equations, and you use something called matrices if you're doing it by hand, or that's when you set it up into a computer, but you still need to know how to set up those systems. So focus on that. So I just started writing this out. I wrote 250x plus 1, or 2.50x plus 1.75 times the quantity 105 minus x to represent my y value. I did solving by substitution, equals 228. Now I'm going to distribute and combine like terms. So I have 2.5x plus my 1.75 times 105 is 183.75, and then minus 1.75x equals 228. Then I'm right here, I'm going to combine the 2.5 minus 1.75 gives me 0.75x. Subtract 183.75 from both sides, and I get 44.25. So this process of math here, this algebraic stuff, should be very familiar. I'm going to divide both sides by 0.75, and I end up with x equals 59, which is nice that I don't have kind of pieces of tickets. It should come out to whole numbers for these if the numbers were chosen accurately. And then we have our y we need to figure out. So again, we usually like to go back into the original problem, but this is pretty straightforward. I mean, it's not been manipulated very much. So you just know what's left. So 105 minus 59 gives me that y value of 46. Okay, so just, double check that everything fits and is nicely together. You can again write that as a point, but because it's a word problem, we're going to write it as a sentence here in our last part. So we have 59 adult tickets were sold, and adult tickets were sold, and 46 children. Oh, it says how many went, so let's reword that a little bit better. Say 59 adults and 46 children went to the concert. I'm not real picky about how you write your sentence as long as you have some kind of meaning attached with it, and that you're answering the question in some way, shape, or form. Like if you had put dollar signs on these and said, this is how much money we made, like that's not what the truth is. So we have to make sure we have the right context in units. So we're talking about numbers of people here, not like how much money was spent. So those are the key things I'm looking for. So remember, this is part A, part B, part C, and part D, if we're talking about our problem-solving process. So you should see all that. Now this one I would like you to do for classwork. This again should look very familiar to you. So pause the video, do it as classwork, but set it up as a system. You can do it as the, x plus y. It's the same type of problem with the quantity equation and a value equation. So that'll be your system. And then you can solve it by substitution. You could graph it. You could choose whatever method you want, actually. I might actually do it by addition, elimination for you, just so we review that one. Okay, so pause and try that and check back. Okay, so if you went through and did that on your own, the answer is over here, so you can see what that is, if you were right or not. If you were totally right and you want to move on, then that is fine. If you want to check it out, how I'm going to do the solving by addition method, you could do that as well. So here's the answer is $2,400 loaned to the first company and $2,500 was loaned to the second company. All right, and now for this one, I'm going to solve my system, which is x plus y equals 4,900, and the quantity, that's the quantity one. The value equation is 0.04x plus 0.13y equals 421. So in order to get a match, I have to multiply this, well, I'm going to multiply the top one through by negative 0.04 and distribute it. So then I'll end up with a new equation. So I'm just going to bump those right over here. So I'm going to have negative 0.04x plus negative 0.04y equals negative 196, that comes up to be. And then we have the second equation I didn't manipulate because I'll have a match right here. So I'm just rewriting that. And then I'm going to go ahead and add those together. And I'll end up with these x's canceling out. So that's the elimination by addition. Okay, that's why we want to match on the coefficient. We want opposite sign. Okay, so we're going to add these here, negative 0.04y plus 0.13y, and I get 0.09y. That comes up to equal 225 on the right hand side. Divide both sides by the 0.09, and I get y equals 2,500. So now to finish this out, I could go through and eliminate the other variable, but I'm not going to do that. I think this is pretty straightforward. I don't have fractions. Sometimes when you end up with fractions here, backsubbing is more challenging than just eliminating the other variable and working with it. But in this case, it's pretty straightforward. So I'm going to just backsub here this 2,500, go back up here for y, and then I just solve out x plus 2,500 equals 4,900. Subtract 2,500 from both sides, and I get x equals 2,400. So then I just write my answer, and that is in money. So make sure you track that. And I already wrote the answer there, but I'll just write it again. $2,400 was loaned to the first company, and $2,500 was loaned to the second company. So just be careful, just because I found Y first, so sometimes people might just pop that in as the first company's, amount, but it's not, because Y represents the amount loaned to the second company. That is one reason why we really get you in the habit of declaring these variables. Really, really important, especially as you move on in math. It's critical, because you have to make sure, does your end answer match the beginning? Did you how did you describe your variables when you find them? How do you know how they all fit together? And make sure that's accurate, makes sense, it's reasonable, and you can interpret. Because believe it or not, it's going to get a lot more complex than this as you move on. It's a lot more fun too. So that's, I'm going to stop there for these two problems on page 64, and then we'll move on to a couple of different types of problems, similar from what you've done before, but a little different twist. Have a great day.